Hello, welcome. Today we are going to be looking at algebraic notation of sets. And we'll also be looking at the different types of sets where we have empty sets. Empty set is any set that does not have any element. Empty set. Finite set. Finite set is any set that the elements can be counted. Infinite set is any element that any set that the elements cannot be counted. Now we also have the joint sets with elements that are not the same. Then we also have equal sets that have elements that are the same. So we'll be looking at all this today. Number one is algebraic set notation. If you look at these two sets, Q is a set of X such that X is prime numbers less than 25, and Q is a set of 2, 3, 5, 7, 11, 13, 17, 19, 23. These two sets are the same. This set Q and this other set Q, both of them are the same. Only that the first one is written in algebraic set notation, whereas the second one is written explicitly. Is that clear? Is that clear? David, is that clear? What is the difference between these two sets?
Now you're written in word and now you're
Good. This one is written in set notation, whereas this one is written explicitly. So we say this is when elements of the set are not explicitly written. So whenever you don't write them explicitly, you write them in what we call algebraic set notation. Is that clear? And look at the way it is read. Q is set of X so that X is prime number less than 25. And you can see that all the prime numbers that are less than 25 are 2, 3, 5, 7, 11, 13, 17, 19, 23. So in subsequent classes, I will be giving you assignments. I will write in algebraic set notation. I will require you to write it in the explicit form. You understand? Now check out this second one. F is a set of X so that X is a member of integer. And this integer ranges from 5 to 14, with 5 and 14 inclusive. Is that clear? You see, the representation is all the integers from 5 to what? 14. And you know integers are whole numbers, isn't it? So we have 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Why is it that 5 and 14 are included? Because we have equal to signs. If there was no this equal to, if it's just less than, we would have had from 6 to 13. Is that clear? But whenever you have equal to, it means that the extremes are included. You understand? Between 5 to what? 14. Is that clear? So this is what we call algebraic set notation, and this is the explicit form of writing the sets. You understand? So these two sets are equal. These two sets are the same thing. Only that one is written in algebraic set notation and the other one is written explicitly. Is that clear? Now we look at the types of sets. An empty set is a set without any element. An empty set is a what? Any set that does not have any element. This is how you say this is an empty set. Is that clear? What's the difference between this set and this set? This other set, this is not an empty set because it has element what? 0. This is what we call empty set. Set without anything. Another word for empty set is null set. Another word for empty set is what? Null set. Finite set. Finite set is any set that has elements that can be counted. Is that clear? Finite set. Any set that has elements that can be counted. Like set of local governments in Nigeria. How many local governments do we have in Nigeria? 774. Is it not? So it can be counted. So it's a finite set. Give me another finite set. Number of people in this class. You can count yourself, isn't it? But if I say set of odd numbers, is it finite? There are plenty of numbers you cannot count. So any set, any elements of set, any set that has elements that cannot be counted is known as infinite set. Like set of odd numbers, set of multiples of 9. This joint set, when you have two sets and they have no elements in common, we call them disjoint sets. Is that clear? Example, set R has element ALM and set Q has element RKD. Is there any set in common? Is there any element in common between these two? So these are disjoint sets. Equal sets are sets that contain the same members or elements, even if they are not written in the same order. Can you see set C? What are the elements of set C? 1, 3, 4, 7. What are the elements of set B? 3, 7, 1, 4. Why are they equal? They are equal because they contain the same elements. Can you see? There's 3 here, there's 3 here, there's 1 here, there's 1 here, there's 4 here, there's 4 here, there's 7 here, there's 7 here. But they are not arranged similarly, you understand? But they are still equal. So you can write that C is equal to B. Is that clear? So I'm going to be giving us this exercise in set notation to see how we are able to understand set notation, set algebraic notation. Is that clear? So we're going to be doing some examples. Now I'm going to require you to list the elements of the following set. Prime numbers less than 30. List me the elements of this set. Prime numbers less than 30. That's assignment number 1. Number 2, factors of 24 greater than 3. List me factors of 24 greater than 3. So list it explicitly. And finally, R is element of S such that R is element of S such that X is a member of N is a member of N and is between (4) and 20. So what question are you supposed to ask me about N? You are supposed to know what N stands for. Who can tell me what N stands for? Alright, let me just say Z, the one I've told you already, so that later I'll tell you what N is. So represent it such as X, please put S here. So give me these sets explicitly. In subsequent classes we'll look at them. Please, if you like this our video, click on the subscribe button, like and share it. Thank you, God bless you.